everyone. Here's a little bit Infer, which is a static analyzer.
You speak up a little bit?
We speak up a little bit.
There we go.
So why are we in this room today? It's because programming is hard. It's pretty hard, and it's when you program and you want to write code as much as possible, you need to think of all the possible cases. In the worst case, you need to keep track in your head of the possible values that this function can be called with, or that can flow through your program from the user. If something can be known in your program, it will be known someday for someone, and your program will crash. And if you ship bugs to your users, then they won't get paid. They sometimes need to take active steps to get rid of the bugs, for instance, upgrade their app or services. So what do we do to combat that? In engineering, well, we try to get code. Yes. So we develop coding practices. We test functionality. We try to architecture the code in a way that minimizes bugs of the boundaries. We add more tests. And then you can also pick a language that has more or less more pure bootguns or pitfalls. Does your language have null values, allow objects to know, or you should use Java and you manipulate files, for instance, you should destroy the resources so that you don't forget to close the files. On your language, you can have more or less free check system, which will also prevent a range of issues. Although you can always choose your language, there's tons of hardware there. Code bases sometime in your life. Or you have to pick a particular language to please a particular vendor. So in this talk I will talk about static analysis, and it's just one additional way to give signal to developers that the code is good to go and doesn't have too many bugs. So in contrast to testing, static analysis, the way I will present, attempts to check all program paths and all values at the same time and ensure that the program works in any case. And you can also think of it sometimes as palliative from key language features. For instance, if your language, for some reason, decided that all objects could be null and there's no way to know except to test at runtime, then static analysis could be a way to make sure that things are not null at the point where you do runtime. So, Infer is such a static analyzer. Written in Camel. It analyzes Java and C family of language, C, Objective-C, and we added C++ support last year. We're still working on that actively. And the main characteristics are it's inter-procedural, so it will track flow of values from functions to functions and across translation units to find inconsistency in the code. So something can be done deep inside the function code, and you do it deep inside another function code. And the other characteristic I want to stress is that it's incremental. So it's very fast at analyzing code changes, and that's very important for those who use it. So Infer is on GitHub. Using amount of stars. This is from back when the open source was failed. People at the time seem to like it. Since then, we've opened collaborations with other companies, so Infer is not used only at Facebook. It's used at Spotify, at everyone, at Uber, and more and more. If you want to use Infer, you can visit the website, and you have two options. You can get started on your code base, or you can even try it in your browser if you want to quickly test some functionality. This is an old version of Infer. It gives you the idea of what you can do for Java. So that's it for the introduction. I will start with a quick demo. So this is a tiny project. It's a bunch of C files and the make file. Create that make, it compiles the file. And if I want to run Infer on this, first make in. So because Infer will just we use you pass the build command that you use for your project to Infer, and it will hijack the compiler and the compilation tool and the compilation build system to figure out what it needs to build, and then it will hijack the compiler calls to read the source file itself and analyze them. So here we see that it's detected by make mode. This is make talking, then it's compiling the files. And then once these are captured in this state, then the analysis starts, and here we find three issues. One is not the reference, so not here, so there's point above, which I got here, is the reference here, and put it out. Also, it should be wiki memory, and so this one we can understand straight away. We declare a null pointer, and we did reference it, and so we'll show you also this. So we can explore the report using another tool that is using purple.
Hey, Jules, will you try to keep the terminal up at the top so we can see it?
We try. So yeah, it displays a big trace, which you can read through. It's informative, but let's do it in Emacs instead. So here it repeats the bug, but then we see the actual symbolic trace. So these are the steps of symbolic execution that are followed to detect an issue. So it says, I entered in this other procedure, and if you go inside, it's in another file, and it analyzes also made a connection between the two. And so you call this procedure, which calls map. There's this suspicious bit of comment code, and then here you get to here, and the trace says condition is false. So P not equal to null is false. So at this point we know P is equal to null, and we return P. We get out the function, and now what that means is that bug is not here. And then we get into get page, which is again another file, and what we see is this procedure just the reference is pointing. So there you go, you have another reference. So what we're going to do to fix this is assume that malloc doesn't fail. And then we're going to rerun Infer, and if I rerun make here, what you expect is that only a file that I changed will be compiled. So you can tell Infer exactly that it has to capture some reactive change, it has to react to a change that I'm doing a full analysis. So it will not discard what it captured before and what it analyzed before. It will just capture whatever is new, so it just person.c, and reanalyze just that file. And then the files that depend on it. So here, in particular, it's reanalyzed pod.c because it depends on person.c. And so now you see that there is one pure bug here because we reanalyzed all the things that depend on our range. So then the memory leak is should be easy to fix. We don't need to get a trace for that. So here we get a new object Bob, and we get some field Bob, but again, Bob is still live. We haven't freed it. So what we need is we need to remember the age of Bob somewhere. I rerun again. I only get my this issue. I don't believe the real issue, so we'll look here. Okay, so this is a quick glimpse of what Infer can do. It was very simple my project, but you can in practice run some very large projects, and it supports an array of build systems. And the kind of in fact it finds, we'll go over quickly there on the website, and there's more explanation there. But briefly, for C, C++, there's another reference memory leaks and resource leaks. So if you open a file and you forget to close by the descriptor or things like this. So very, very thin memories. For C++, it doesn't quite do the array-bound checks yet. That's the hard problem in static analysis, so we haven't quite come up with something we're happy with it, but stay tuned. But what it can check is, which is a pattern happens sometimes, is the vector is actually empty and you try to access an element. So this is easier to check. It also detects static initialization, although Casco, it should be included valid before you know it, and I don't know the name. And a bunch of other things. We do Objective-C because we run on iPad for iOS. So there, the only thing I'll mention is that with Infer detects retain cycles, which are cycles in the memory that defeat the simple counting garbage collector babble. So you learn on that. And so this is an example of things that static analysis can help with. If your language has some issues with this. And for Java, there's a GC, so we don't care about memory leaks, but we still have another reference on resource leaks. There's a tape analysis, referring to that. There's, that's an interesting because it came for some engineers asked us to do that at Facebook. So this is something where you can annotate some methods as performance critical in your code, for instance, things that run on the UI thread in a mobile app. And you can annotate other methods as expensive. And then Infer will check for you that there's never a call chain from a performance critical method to an expensive one. And others. You can see the website. We have also some Android specific checks like context lists and fragment. Thank you. So I mentioned that this was just a toy project. For instance, we run on DuckDuckGo, which is the app for the DuckDuckGo browser search engine. Sorry. So here's an example bug. So the report by Infer was there's a resource you acquired at line 2 and it's never released at some other line. So what that means in the code here is we annotated the resource here by doing this DB query. And here there's an if branch. And in that if branch you can return from the function before you put close. And so here you leak the cursor. So that's that. Another example is Moody. So here what do we have? It says that this field object here from this nested method call can be helped. And then it's the reference. Let's see, it goes into the function, which initializes things to mount. Then it does a DB query, there's an if. At this point, the cursor can be empty. And we get so we don't ever enter that branch, and we get the finally, we close it, and we return out, which we never changed from the beginning, so it's still null. So here, the end of the story is field_elect is null at this point. And we go inside this other function, and Infer, when it analyzed it, so that one of the things it does is it references the farm. So here we got an empty. Okay, that's it for art. So I will say a little bit about how Infer works generally. Not going into the details of semantic execution algorithm or anything, it's just the various phases of the Infer runs. So that's helpful to understand how to use the thing. And then I will tell you the story of how we use it at Facebook. So the architecture of Infer is roughly this. So this is your program. It's a bunch of source files and the build system that knows how to compile them. And these are the things that Infer supports. And so the first thing is it goes through the function, which knows how to drive the build system to get to the source files, and it translates the source files from all these languages into a common, very simple intermediate language called C, which is basically just go-tos and loads for an assignment. And then once it's captured all the lines in your project, it starts the analysis. And so for each procedure that it found in the source file, it will produce summaries. And if at some point to produce summaries, it will attempt to prove that the procedure has no bugs. At some points, it will not manage to prove that, and at that point, it will decide whether to report that as a bug or not. So let's dig into the first step, capture. So here's a simple Java class. Let's look at this method. Compute something. So it tests the flag pass as argument, it can compute that like a note or something. And the front end, we translate this method as a simple control flow graph. So here, obviously you cannot read this, but what you can see is you can see the two if branches, and these are the instructions in each branch. So you're just assigning a string, and then at the end, both branches join to the exit node. So that's it for capture. It does that for all the source files, and we will translate each procedure as something like this. And then the analysis runs on those small CFGs, or big CFGs, no matter. And what it attempts to do is it attempts to understand, to find specifications for them. So what do I mean by that? So for instance, for this method, it will discover that if the parameter is false, then it will return something. And if it's true, it will return null. And so the state before the procedure is called a precondition, and the state afterwards is the postcondition. And together they form a specification of the function. So if you start with this precondition and you execute the function, then you will start at the postcondition. And so for this function, there are two specs because of this chunk. And then if we look at the other method, it calls the first one. Stores the result into rest and tries to compute the rest of them. And Infer is smart enough to see that this function depends on the other one, so it will, or if it hasn't already, when analyzing this method, it will realize that it needs to first compute specs for the other one. So at that point in the method, it will have these two specs for the callee, and we call compute something of truth, so it will look which specs make sense of that. And only this one makes sense. So when you call that function with true, you know that it returns null. So at this point, you know that S is null, and the next line is bad news because of zero referencing. That's it for how Infer works. In its main mode of operation, I want to briefly talk about two other modes of operations. One is eradicate. So in Java, object can be null. If you wish it wasn't so, you can use eradicates. So with eradicates, you can annotate objects that can actually be null with add model, and everything else will be assumed to never be null. And what eradicate does is it will check that the whole code base is consistently annotated in that fashion. And what that means is, and whenever you dereference something that was marked null, then you better check for that before, and otherwise eradicate will yell at you as well. And so if you do your whole code base like this, in theory you should have no runtime, no pointer exceptions. So it's like a type system on top of Java, rather than the main mode of Infer, which tries to really track values. Another mode is for the client side of Infer. We have linters, which are simple zero check, which are just syntactic, and walking over the ASC and looking at the nodes. And what's interesting is you can write your own checkers easily. Either inside Infer, you can add them in Infer if you know to write camel, or you can even use the simple DSL we have. And I want to just show what one of these checkers can look like. So this is a checker tracking a vacancy. A property with a point type should not be declared assigned, whatever that means. And so the checker for that is just this struct that says when to report, a message to report, and the checker triggers, and the fix just and so when to report is easily expressible here. It's if this is a signed property, then if it's a pointer type, and if I'm inside an Objective-C property decal, then I should report. So, and you can write a further range of checkers using this language. Okay, so now you put this, deploy it for the project. I'm very happy to hear that. Thank you. So how does it work? So at Facebook, when the team arrived, they wanted to analyze the mobile apps. So now we're looking at millions of lines of code and and so there was a question of how to do that, how to surface bugs to developers, because you have this tool that can output a list of bugs, and you have people working on different things. So the first thing they tried is just an Infer, get the bug list, and try to be smart about assigning bugs to the right person. I see some people in the room know about that. So that didn't work so well. It turns out anything a couple weeks old is already history for developers, so completely switched to a different task by then. And if it hasn't caused a crash in front, then it's anyway. And for bugs reported by static analyzers, it's very hard to know if there are actual bugs or not, because the analyzer only analyzes functions locally, and it doesn't try to start from entry points or things like this. And so the metric here is really seeing the bug. Does the developer think it's worrying enough that he will fix it? So instead, what we found out is we have to integrate Infer inside the development model of developers. So when the code is fresh in their mind, and the best time to do that is at diff review time. So you have for submitting code to review, and Infer will comment on the code just like the rest of the CI and other reviewers. So developer sends a diff. And so this is more or less set up at Facebook. We use Fabricator as our code system. It's also open source. So the diff goes into the CI, into Fabricator. The CI runs a test, and one of the things it runs is Infer. Meanwhile, the code reviewers give their opinion on the code, and Infer will try to find issues with it. So for instance, let's say it found a bug. Then what the developer will see is something like this, just a message like the reviewer's message or the same message saying, oh hey, here, I think this can be another reference. And then at some point everyone's happy, and Infer is happy as well, and the diff goes to work. So in a bit more detail on the Infer side of what happened here, what happens is under the hood, when we get a diff, we run Infer on the top revision, one with the diff, with the changes of the developer, and we run it also on the version, the base revision of it, so before the change. And then we compute only the new bugs, the one introduced by the diff, presumably introduced by the diff, and we report those. So we don't report all bugs, because as we saw, developers are not really interested in fixing those. And we report only new bugs, and this way this gives high signal to the developers that they're responsible for the deficit, or at least find a good story as to why it's not an issue. So for now, these steps are Infer another really support for helping you do that. You have to run Infer out and do these things. Again, because the business logic do that is in Facebook CLI, not in Infer itself, but these days we're working on bringing that logic into Infer itself so that more people can benefit from this work. So, yeah, that's it. So every month Infer runs on thousands of modifications on those mobile pages, and it reports hundreds of times per month, and that is fixed by developers. And what I was talking about before, what we measure is the rate at which people fix bugs. So we want that to be very high, otherwise people will start ignoring the tool, and then it's game over because most people are trying to come back. So approximately 70% of the warning that Infer gives out. And that's it. Thank you for listening.
So, analysis how well analysis work on that.
So the question is, does it work for recursive code? So you mean two recursive functions in the code? So in theory, yes. So Infer used to. So in theory, what you do in the theory in Infer is when you have mutually recursive functions, you start by using any one of them, and you analyze the others based on the results of that, and then you go around the loop some amount of time, and you convert them. And then at some theoretical point in the future, the specs will stop changing. In Infer, in practice, we go around the loop twice. I think that was a user heuristic. I think now we don't go around the loop. We go around the loop only once. We start somewhere, we give you an empty spec, and then we go around. Because in practice, people don't write that many functions, so we haven't found it. But if someone wants it, I mean, the theory supports it and the tool supports it. It's a matter of somebody cares enough that they can add to it. Yes?
What do you resolve that? When you have dynamic pointers, when you have text groups, to external functions you didn't know, or just trading?
So the question is, how do you compute control programs given that there are external functions, loops, function pointers, and dynamic dispatch and the like. So there are several issues in what you mentioned that all need to be tackled, and the answer. So the CFG itself is just a representation of the EST, so it's nothing particularly there. But for instance, it's a dynamic dispatch. So when you go to a method call, and you have to do method resolution, and at that point, Infer will track the precise type of the object you need, and so you use that type to figure out which method. And what that means, what dynamic dispatch, the biggest hurdle we had to overcome was that the call graph is now dynamic. You can first start by computing your call graph of your whole project and start analyzing function in order, starting from the values going to the callers, because you don't know which one is calling which other one. And so the way we cope with that in Infer is an on-demand analysis. So when we get to a call site, it could be that we haven't analyzed that function yet because it's dynamic dispatch, and we didn't realize that this was a callee. And so at that point, Infer knows how to, somebody's doing, go analyze the other function and come back to one system. But these are all very good, very tricky issues, and we solve them in dispatch, and we do sort of thing, function pointers. solve all.
Search some of them. So which of them you go?
So what was your list again?
Multi-threading.
So multi-threading, Infer assumes everything is sequential for now. We're starting to develop a concurrency analysis in Java.
Alright, and afterwards with external functions.
So calls to external function, that's an interesting one. So we have two approaches here. One is for libraries that are used often and for which it matters. We have models inside Infer, so it knows what's a hash map, what it does. A bunch of things like this. So you can always add models. And in general, but the basic thing it does is if it finds a function that it doesn't know anything about, then what you do is what we call inject mode. We'll assume that function does the best possible thing for the rest of the program. So if it returns an object and you get to reference it, then oh yeah, it was probably allocated as a function. And doing that, we found we enabled us to analyze a lot more code than when we used to be more pessimistic. Yes?
So you mentioned that 30% of the data is now fixed because of FOSDEM or
so the question is that there's 30% of issues that are not fixed by developers. So as I said, it's impossible to make this thing a false positive. We spend weeks in one bug trying to figure out things and produce it. So we don't try to measure that. It's not possible.
and interview the developer, like you say, right on campus.
So what we do is, in our team, we have someone look at the bugs that have been ignored by developers in several iterations of their diff, and we go look at those and we have a discussion with developers. Say, oh, maybe let me fix that. It's like a bug me, or oh, sorry, this is clearly a false positive. We try to improve Infer for that case. So we improve the tool continuously based on that.
For C, which compilers are supported here?
So the question is which compilers are supported for C and C++. So the answer is can.
So you will need to try the intermediate language for C and Java.
So
To do the analysis, not on top of the source code, but on the intermediate language.
So to elaborate, so we do the analysis Clang on top of the Clang AST. So we start from AST. For Java, we start from bytecode.
That means on top of this Scala.
The question is, can we do Scala? Yeah, in theory we can, but the thing is we have, I mean, there's no particular difficulty there, but we don't have a mode where we can just give bytecode inference and we'll analyze it. You have to give the source code. How long you're blocked on. But if somebody wants to analyze that, then they have to. Yes?
How do you compare with OOB and static analyzer? Because there is one static analyzer.
Yes, so the question is how does it compare with static analyzer? So there are a bunch of static analyzers in the wild, and what we found out when trying to compare them is that they all report pretty much different sets of bugs. So the best strategy here is run them all.
But in terms of number of the more bugs, we run because it's kind of not discussion because you will find like people you find anyway they will find a certain number and it is faster, more stable.
So the question is, let's actually answer the question. So, I don't have a very good answer to that. I can point technical differences between the tools. For instance, Clang static analyzer is limited to analyzing a single translation unit, whereas Infer works across translation units. In general, Infer tries to find sort of debugs. It's pretty interprocedural, so it will find bugs sometimes across long code chains, and I haven't seen that very much time. And it's also not looking necessarily the same defense. Yes, please.
How this works in integration and how to vary last?
Pardon?
This works in integration and, for example, vary last.
I'm sorry.
How to vary the object Spring integration.
Spring integration in Java.
How to vary in Java.
That's
It's an easy job also.
I don't know what that is.
That's your answer. There was another
We
guy
can talk offline.
right here.
Yeah, we can teach you about that. Have we considered rendering the reports in each round? Yeah, that would be great.
Thank you.
Do you plan to put Infer on popular CI tools like Jenkins or?
So do we plan to put Infer on popular tools like Jenkins? So I don't see any difficulties with that. So I don't think we want to do that ourselves because we don't use it, so it doesn't make much sense. But what we're doing, as I said, is we're trying to put most of the logic you would need to do that inside Infer, like, so that you could say Infer diff analysis of this and that, and then it will automatically just do what I said, organizing the top revision, the base revision, and then the reports from Infer are simple JSON objects, so hopefully someone will write some interface for that.
And keep going.
I want you to phrase the question for the for Java Enterprise notations, dependency injection, and stuff like that.
Ah, right, sorry. Yes, so dependency, I think all that is resolved before we run, because it's not very good. The question was about Java. Yes?
Do you have any ideas for
Do we have any ideas for it? Not at the moment. It would be nice to have.
you have email support?
Very good email support. It's not really support. It's just the URLs are formatted in a way that editors like email systems, but in that there's nothing to put in TJ to run for an exchange.
Another question. Infer isn't.
Infer is written in Camel.
You said that you run on diff, just on diffs. This implies that you need some data storage for storing some state for previous binary.
Right, so the question is, you mentioned that we run on diff, so does it imply that we make some external storage of shit? So, not really. So, no, because what we do is we really run Infer on the diff and on the base revision, so we run it twice for every diff, so that we can do a comparison just local. So, but the longer story is, most of our projects use Bug, and we use Bug cache to cache the results of the analysis. So it's very often the case that some parts of the analysis results are already in the cache, and we don't run it. Yes?
If I recall correctly, I saw one slide where the output from Infer was pushed to a source code management system or review system. Was that correct? Or do you support integration with, for instance, Bucket or GitHub, that the remarks of Infer come into the review pane?
So the question was, there was one point where I showed an Infer command inside a review tool. So it's just integrated Fabricator, and that's not even Infer talking to a Fabricator API. It's just the CI reading the results from Infer and then looking at Fabricator. So we don't really have this sort of integration, but that's something we're hoping to build. Or build tools for people to easily integrate.
You showed the slides on the Java build. There's a lot of comments on the build. Is that really true?
There was a lot of commented code where I showed something DHE. This guy? Yeah. That might be the fix. do we have tools for scripting languages? We don't have tools for scripting languages. But everyone is willing to write their own front-end for their scripting language and interface with Infer. So the thing is, it's just a matter of writing a compiler from your language to Infer. So what we did, we support all languages, basically. So if you emit the intermediate language, then you can interface whatever content.
Do you have times for larger projects like Firefox or LibreOffice or something like that? How long it would take to run on that? For example, for LibreOffice, it's
So the question is
run more than a day.
Sorry?
For LibreOffice, conversion runs more than a day. That's why
Right.
we just get analyzed for
I don't think
one.
I'm allowed to hear information about the variety, so
So I'm running it
So
on,
the question is, how long will it take on big projects such as Firefox, and I will delegate.
so I'm running in Firefox, so for Java it takes like 1 hour, bit less, and for C it's less than that because we don't have messaging and so in a CI it's working perfectly fine. In feedback would be good.
So the answer is on Java it's less than 1 hour. What in the defaces, I can give the Facebook side. On this, we aim to report within 10 minutes, and so our P50 is probably around that. P95 is much worse because of the dependencies in others. Sometimes a small change can trigger. And it also depends on much is in the cache.
Actually, the Kotlin bugs and the fix must be going to apply. Do you look when the bug fix and how people fix them in a way? It's what also people
Okay,
question.
so the question is, I mentioned that we go look at bugs that people don't fix, and do we also look at bugs that people do fix, and how do they fix them? Sometimes we're very anecdotally because mostly if the bug has been fixed, then we first stop reporting at some point, so we have it. And don't really much more into that.
But do they, I know there's like tests to do a straight bug, for example. People just do line and infer, and you have people.
Okay. The question is, for example, there were tests to make sure the bug is gone. I don't think they do, so these are not runtime bugs, these are, not sure, that's the question. So, one thing is Infer will be running on the next tips as well, so if you found it this time, you will find it the next time, so maybe originals have come to rely on Infer a bit less. No more questions? Okay, thank you very much.